Hello viewers, in today's class we are going to discuss one important and conceptual problem from Maxima and Minima, right? And this problem is going to be very useful for the beginners, right? So let us start. So here we have to find the maximum value of this function f of x, which is equal to absolute value of x times log of x for x belonging to the interval 0 comma 1, right? So we have to calculate the value of the maximum value of this function when x lies between 0 and 1. So here we see that we have the mod function, right? And x belongs to this interval that is 0 and 1, right? And we know that x is positive in this interval that is 0 comma 1, right? And here we have the log function. So this is the natural log, and from the properties of log we know that log of x is negative for all x belonging to the interval 0 comma 1, right? So whenever x lies between 0 and 1, then the logarithm of x is always negative, right? Okay, so once we have x is equal to positive and log of x is equal to negative, so it implies that this product, that is x times log of x, is positive times negative, right? So x is positive, log of x is negative. So when we multiply a positive quantity with negative quantity, we get a negative quantity, right? So f of x can be now it can be written as negative of x times log of x, right? So this we have written by using the definition of mod function, right? Because mod of p says that mod of p is equal to positive p whenever p is greater than 0, mod of p is 0 whenever p is equal to 0, and mod of p is negative of p when p is less than 0, right? So here we see that this product x times log of x, if we take this product as p, then p is negative, right? So it means p is less than 0. So when p is less than 0, then mod of p is negative of p. So that's why f of x is equal to negative of x times log of x, right? So now we have this function. So now let us differentiate this function f of x with respect to x, right? So let us find out f prime of x. So we have minus here, then we have the derivative of x times log of x, right? So here we can use the product rule. So first we have the first function, then the derivative of log x is 1 over x, then we have log of x, and then we have the derivative of x as 1. So here x and x get cancelled, so we are left with minus 1 plus log of x, right? So the first derivative is equal to negative of 1 plus log of x. So let us find out the second derivative, right? So here we are going to use the second derivative test to find out the maximum value of this function f of x. So the second derivative is negative of the derivative of 1 plus log of x, and we can see that here the derivative of 1 is 0 being a constant, and derivative of log x is 1 over x, right? So this is negative of 1 over x, right? So once we have obtained the first derivative and the second derivative, let us find out the critical points. Now to find out the critical points, we must equate the first derivative equal to 0, right? So the slope must be equal to 0, or the first derivative, that is dy over dx, is equal to 0 in order to get the critical points, right? So here f prime of x is negative of 1 plus log of x, that is equal to 0. So we have 1 plus log of x equal to 0, log of x equal to negative of 1, and we can write here minus log of e, right? So e is the exponential number, and we know that logarithm natural log of e is 1, right? So 1 is replaced by log of e. So we can now write log of e raised to minus 1 by using the properties of log here, because n log m is the log of m raised to n, right? And now taking the antilog, we have x is equal to e raised to minus 1, that is 1 over e, right? So the critical point is 1 over e, right? So now what we will do, will test this point x is equal to 1e uh, for the second derivative, right? So here for x we can now substitute x is equal to 1 over e. So we can see f double prime, and here we have 1 over e, and here we can now write x is equal to 1 over e. So we have minus 1 over 1 by e, that is minus e, right? And we see that the second derivative is negative, right? So f double prime of 1 over e is equal to negative of e, and e is a positive quantity. So minus e is negative. So by second derivative test, we can claim that this function f of x is maximum at x is equal to 1 over e, right? So according to second derivative test, if the second derivative comes out to be positive, then it is minimum and the function is minimum. And when the second derivative is negative, then the function is said to be maximum, right? So here we get the negative sign, so the second derivative is negative, hence this function f of x is maximum at x is equal to 1 over e. Now to get the maximum value of f of x, that is the maximum value, what we will do, we'll take x is equal to 1 over e in this function, right? So we have minus 1 over e, and here we have log of 1 over e, right? So now we have minus 1 over e, and 1 over e can be written as e raised to minus 1. So we have minus 1 over e and minus log of e, right? So minus times minus, this is positive. So we have 1 over e, and log of e is 1. So here we have 1. So we have 1 over e, right? So this function is maximum at x is equal to 1 over e, and the maximum value of this function when x belongs to 0 comma 1 is 1 over e.